there comes a time when using generics in Swift programming language where you've got associated types on two different protocols, and you need to make sure that these two types are the same. All right, but and this is where the strength of adding constraints to an associated type comes into play. So let's just quickly talk about where the possible problem could be and how you could solve it. So we've got a view model protocol here, and we have a view protocol here. All right, now the whole idea is that this view protocol needs to have a view model protocol as well, and essentially they're both representing the same type. All right, and as you can see here, the view model has an item, and you say get item, and then the view model as well. So the view, show item, and it's a little bit of a silly example, but this function is just going to show it, and it's going to return it as well. But this is the whole point behind this, is that they both utilize the same types. Okay, now what we could say in here is, because this associated type of item is different to that of item. So let's just prove this first of all right? And so let's create a view, and it's going to conform to the view protocol, and we say show item, and it's then going to return item. We now need to add a type alias to view model first of all of type, and we're going to extract that out to here, and we're just going to say view model protocol and put that in there. We're going to solve that for the time being, and now we're going to say item is and we'll put the item u in here. All right, and so we'll just make a type alias here to item as equal to u, which means we can say u in here item, and we do this. All right, so when we try and create this, we're obviously going to need a view model, right? But right now we don't necessarily have to have a view model, but we're going to need one to instantiate it. So let's show the problem that we have. We create view, and we'll say that item is a string, and you can see here generic parameter t could not be inferred because we don't have a concrete type for this yet. So let's start by making the view model, and it needs to implement the view model protocol, and this is going to have a get item, so it needs to have an item here. And when we say item, we need to have some form of type, which we can do here. So let's say type alias item is then going to be equal to string, just for the sake of having some type here. And now we can start to say what type this is, and we can say view model here. And what do we get here? Generic type view specialized with too few types, got one but expected two. Okay, well, we've got the view model protocol here that we've told it that it's a view model, and then we want to come here and we want to say string is the second one, and now the view is fine. All right, so we can see here that we've got the view has got the item. So are we getting everything that we want? Yes, well we are. So when we say view and view show item, what type do we have here? We have string. All right, well, right now our view model is returning string, and our view is taking a string. Okay, so what about if we want to change the item to actually be let's just call it an item type of type struct here, and just make it have some text here. All right, and when we create this here, we're going to say then an item type, and then the text is then hello world, because we want it to be generic, we want it to have any type. So cannot convert value of item type to expected argument string here. Well, that's fine. We've seen this already. We can change our u to be of item type, and now we get the item type here. So we're happy. But wait a minute. Our view model says that we want to get item. So we want to get the view model item here, and when we say that the view model, we don't actually have a view model in this view right now, so we're going to have to add a view model, and that's going to be of type view model, and then we can instantiate it here. So now we need to have a view model here instead, and we want to have a view model here instead, and we're going to say view model get item here. Okay, let's just ignore these errors for the time being, and we're going to need to create a view model and say view model. So let's just create one here, and we create a view model, and the view model has an item. So let's see what type of item it needs. What did it say? View modeled item. So let's put a string in here and see what errors we get now, and we'll say view model gets item. And are we compiling first of all? No, but down here seems to be fine. This doesn't worry about it, but here it's not liking it. Cannot convert return expression of t.item to return type view tu item aka u. So let's have a think about this now, right? Our view model get item is returning an item. Our view protocol is saying show item, returning an item. So what we want to know is that the view model's item is the same as the item, right? So we're going to constrain the associated types. So we can do this in a couple places. So we could come here in the view and we could say where, first of all, t.item is equal to u, right? And this forces now the error to come somewhere else. So inside of our view now, it's all happy because we know that get item is the same as the view. So the view model get item is the same as the return type of show item, because we've now said they've got to be the same type. So now you can see view requires that item type and view model item, aka string, be equivalent, because now we've got two mismatching types here, because we've got string, right? And we've also got then item type here. So what we need to do is we need to come here and generate a item type here, say hello world, and compile it. Cannot convert value of item to expected here, aka string, because view model is still here on string. So we really need to now move this out to make this one generic, and we're going to make it here. So now we can see return from initialize without initializing all stored values. Well, we've got our view, right? Well, we now don't need this item anymore in there, right? Because we are getting it from the get item. And so now you can see everything compiles perfectly fine, because at our struct level, right, we have told it, hey, t item must is equal to u. But, you know, this is at the implementation, whereas we really want to couple the view model and the view together at the protocol level rather than at the implementation level. So what we can do here is we can say at the associated type, we can say where view model item is equal to item. This will also work, right? So if we now get rid of these constraints and we run this, okay, we've got view protocol requires types to be equivalent, right? So you can see here that we've said they both need to be the same, but there's nothing saying that these two are the same here, okay? So we really need to come back to here and just to confirm that they are both going to be the same. And when we run this, we get, first of all, they couldn't be different in the protocols, all right? So we get some information to the implementer, first of all, to say, hey, this item and this view model item have got to be the same. And then on the implementation here for the compiler, we're telling the compiler, hey, compiler, these two generics have got to be the same as well. So now let's add even more constraints to the associated types. We're going to say that the view model item has to be codable, right? And we're going to say that the view protocol has to be equatable, okay? And now we start running into a couple of problems, because these two, they don't conform to each other. Type view model T does not conform protocol here. So we now need to come back to our view model, which we said that the item, let's start with the view model. The item needs to be codable. So we just need to come here and say on the T that it's going to be codable. Well, that's fine as well. And here the view doesn't conform to it. Well, we just need to say that the item is also equatable. And now we move the problem down to generic struct view model requires that item type conforms to decodable. Okay, well, this is all right. Well, first of all, equatable. Well, let's just solve this one first. So we need to come to the item type now conforms to codable, but we see that it doesn't conform to equatable. Well, strings are equatable anyway, so we should be able to say equatable is here, and it all goes away because all of the member properties of a struct, as long as they are all equatable, then that struct itself is going to be equatable as well. So now you can see that we've used protocols to their full extent here, and we're also using associated types, and now we're constraining the different associated types to what those concrete types should be. Okay, and we're also making sure that the view model and the item that they match with each other at a protocol level, and we're also making sure that the view at the implementation level they both conform to each other. And we are matching because this view is generic, so it can take any different u as long as it is equatable, and the view model can take any t as long as it's codable. All right. So with that said, this is now highlighting to you about how you can start using constraints with associated types. Now, don't think for a minute that you're finished here. There's lots of other things to understand and need to learn about generics, but if you can start seeing and understanding now why I say that generics are Swift's superpower, right? Because it's really fantastic at doing stuff like this. And if you haven't seen my other video about why should I learn generics, why should I care about this type of stuff, but you want to start learning the likes of Swift UI, then it's going to become very apparent very quickly that you need to learn about protocols, and you also need to learn about generics, and you're going to need to learn about opaque and box protocol types, which we're going to move on to in the future. So let's just make a content view here. Let's make it conform to view. Happy days, we're all happy here, and this is going to have a property here, and it's going to return this body here is going to return here, and it's going to return some view, and that's going to return self. And it's really important for you. We've already got view here, sorry. So let's just say, let's just put this to view 1. Put this to view 1. Should be fine. Okay, so now you can see that you're going to start seeing this sum view, and you're going to be thinking, why should I use generics? Well, this is the reason why you need to learn about generics, because all of this stuff, this associated types and type aliases and generics and so on, this is you need to learn this before you can understand this sum, okay? Because sum is talking about opaque types, and if you can't understand opaque types, if you can't understand generics, associated types, and the clauses and this, that, and the other, and the constraints, then this sum is going to be really difficult for you to take on, even though it's on the first lesson when you learn Swift UI. It's a bit funny, you know, in order for you to learn Swift UI, you have to learn this first. So this is why I'm making all these videos, because future developers in Swift UI are going to have some real problems on day one learning the Swift programming language if this is the first thing that they see. With that said, thank you very much for watching. I hope that you've got something out of this one video. I hope you've learned something in this one video. I hope I've opened your eyes up to the type of stuff that you need to learn with Swift in order to make you ready for Swift UI. If you've got any questions, concerns, feedback, then please do not hesitate to start a conversation in the comment section down below. Don't forget to like, subscribe, share, and do all the other social media things that you can do with it. With that said, my name's David Thorne. Thank you very much for watching, and I'll see you in the next video. Ciao, ciao, and goodbye.